Lesson 5.4, Equilateral and Isosceles Triangles. Essential question, can you use the base angles theorem and its converse? Can you find angles and sides of isosceles and equilateral triangles? Let's go ahead and start. This is what the base angles theorem says. If two sides of a triangle are congruent, then the angles opposite them are congruent. I've seen some books write it this way. If you have a triangle with two sides congruent, then the angles opposite them are congruent. Now, this means opposite right here. This angle is opposite this side. This angle is opposite this side. So they're facing each other. And the converse of the base angles theorem. And that's when we exchange the if and then. So if you have angles that are congruent, then those sides opposite those angles will be congruent. So this side is opposite this angle, that would be congruent, and this side opposite here, and that would be congruent. That's what it's saying. All right, let's take a look at the proof. So we have two sides congruent, that's what the given says, and we'd like to prove that these angles are congruent. We're going to do that first by drawing an angle bisector. So step one is to draw an angle bisector. Every angle can be bisected. Now, when you have an angle bisector, you're going to have a pair of angles. So I'm going to put the A here. And remember, you've already been given an S. So we have an S pair, an A pair. Remember, the only shortcut we have right now is side angle side, and we have a side pair and an angle pair. And the other side pair is right here, this reflexive. So the triangles are congruent by side angle side. Now, why is this going to be helpful? Well, this is going to be helpful because we've used a shortcut to get the triangles congruent, but the other parts that we didn't use, the other two angles and the side that we didn't use, are also congruent. So this angle B is now congruent to this angle C. Remember, here's angle B and here's angle C. Since we've proved that they're congruent, those angles are congruent, and this is the statement we use. Corresponding parts, these are the angles that go together, of congruent triangles are congruent. All right, one more time. Here's the theorem again. If two sides of a triangle are congruent, then the angles opposite them are congruent. If two angles of a triangle are congruent, then the sides opposite them are congruent. All right, so let's name two congruent angles. So DF is congruent to EF. So the angle opposite this side is this one. The angle opposite this side is this one. So our conclusion is angle E can be congruent to angle F. All right, let's go ahead and practice again. HG, that's this side, is congruent to HK. So if I see two sides congruent, then I know the angles opposite them are congruent. This is called the base angles theorem. So I can say angle G, this angle right here, is congruent. Now you can't say angle K because here's an angle K and here's an angle K. So you're going to have to use three letters, H, K, G. All right, now I'm going to change color. We have KHJ, which is this angle, is congruent to KJH, which is this angle. So let me go ahead and kind of draw it separately here. So what we have is this angle congruent to this angle. This is H, K, J. And so we know that this side is opposite that angle. And we know this side is opposite this angle. So we can say HK is congruent to KJ. And this is the converse. So when the two angles are congruent, then you can say the two sides are congruent. This is the converse of the base angles theorem. Okay, corollary to the base angles theorem. Corollary means a very short proof where we've used another major proof to do it. And it says that, hey, if all the sides are congruent, it's equilateral, then it must be equal angular. And the converse is also true. So let's take a look at the proof. All right, this is equilateral. That means all of these sides are congruent. So AB is congruent to AC, that means this angle will be congruent to this angle, and that's what we're saying here. And then AB is congruent to BC. That means this angle will be congruent to this angle, and that's what we're saying here. And then AC is congruent to BC, so that means this angle is congruent to this angle, and that's what we're saying here. And by the, you can see that they're all congruent to each other, you know, the transitive property. And so we say, hey, if all the angles are congruent to each other, it must be equal angular, and that comes from the definition of equal angular triangle. Okay, one more time. If a triangle is equilateral, then it's equal angular. If it's equal angular, then it's equilateral. Okay, notice that this triangle is equilateral. Equilateral means all these angles are the same. Now this is a triangle, and we know that they all add up to 180, and if you divide 3 into there, then these are all going to be 60 degrees. All right, we would like to find the length of ST. Now I can see all the angles are the same, so that means all the sides have to be the same, which means these are all going to have to be 5. This is the converse of the equilateral triangle. Converse to the base angles theorem, corollary. Okay, we'd like to find this problem, find this answer. We want to find the values of x and y in the diagram. Right here I see equal angular, so I know this must be equilateral. So this will be 4 and this will be 4. And right now I see here, I see 2 angles are congruent, so I know the sides opposite them are congruent. This is the converse of the base angles theorem. So I'm going to say 4 is equal to x plus y, therefore x is equal to 3, and remember I did get y is equal to 4. All right, in this one, we're going to see I have an equilateral triangle, so that means I know all these angles are 60. And why don't you stop the screencast and see if you can figure out all of these answers. Okay, here are all the answers. I noticed that all of these had to be 60. This was a right angle, so if this is 60, this is 30, and this is an isosceles triangle, this is 30, 30 and 30, and then the leftover angle is 120. And this is the end of the screencast.